Welcome back. Problem 11-11. So statement is the timber beam is to be loaded as shown. If and supports only vertical forces, determine the greatest magnitude P that can be applied. Allowable bending stress is 25 megapascal and allowable shearing stress is 70 megapascal. So this is the timber beam that only supports vertical force at this end. There is a point load at the mid and the cross section of this timber beam is T-shape. All the dimensions have been mentioned. So you have to find the greatest magnitude P that can be applied. So let's start with the solution. So first step is that if we remove this support, so definitely there will be a vertical reaction. Let this is RA and at point B we will have a vertical reaction that is represented as RB. So first we will find this unknown reaction. So how we will find them? We will use this equilibrium condition. First equilibrium condition is sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, the one moment is due to this P load and perpendicular distance is this 4. And this will produce clockwise moment, so it will be negative. The second moment is due to RB into perpendicular distance is this 8 meter and it will be counterclockwise, so it will be positive. Their sum must be equal to 0. So I will write it P into 4 and that will be negative plus RB into 8 is equal to 0. So from here you will get this RB is equal to P by 2. Now we will find RA by using the second equilibrium condition that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So we have three forces. One is RA which is upward and RB which is also upward. So both will be positive, and third one is this minus P which is downward. So RA plus RB is P by 2 minus P is equal to 0. So from here you will get RA will also equal to P by 2. Also you can calculate it directly. You can see this is P, so only this P is supported by 2 reaction force. So P will be divided by 2, so each reaction force will be P by 2. Now we will draw the shear force and bending moment diagram. So we will draw vertical lines from the end. Okay, so this is the length, along the length which is in meter. So you can see at point A we have a load of RA which is P by 2. So let this point is your P by 2. Clear? So moving from point A till this point P, there is no any other shear force, so it will remain same. So it will remain same till this point, till the mid. Now at this point we have a load of P, so P by 2 minus P will be equal to minus P by 2. So shear force will change from P by 2 to minus P by 2. So it will change to this. And again you can see that there is no change in the shear force, so P by 2 will remain same till the end. And you can see that at end you have RB which is equal to plus P by 2, so it will go to 0. So this is your shear force. Now what will be the bending moment? So again you have to draw a horizontal line. This will be your length of beam X. This is your point 0. So at point X is equal to 0, moment will be 0. Now you can see that this area under the shear force will give you moment, and this area is P by 2 into length is 4 meter. And again this will be equal to 2P. So let each point is P. This will be equal to 2P. So we will get this point. Also this shear force is a straight line with 0 degrees, so bending moment will be the straight line with 1 degree, and slope will be increasing because area under the shear force is positive. So you can join them using a straight line, and this will be equal to 2p. Now the second area is this one, and again this area is minus 2p. How? Because p by 2 into this distance is 4. This is p by 2. When you multiply, it will give you minus 2p, and the slope will be downward. So plus 2p minus 2p will bring it to 0. So we will get a straight line, and slope will be decreasing because you can see that this shear force or area is negative. So from here you will get the bending moment. So this is bending moment, and this is your shear force diagram. Now we know that we have stress, bending stress is given as m into c divided by I. So this is maximum bending moment. Clear? So maximum bending moment from the shear bending moment diagram is 2p. Clear? We do not have c and I. So what we will do is you will go to the section, this cross section of the beam. You can see this width is 150, thickness of this portion is 30, this height is 120, and this thickness is 40 millimeter. So again, first of all, we will define its neutral axis. So what we will do, how we will get the neutral axis. So we know that neutral axis y bar is equal to sum of y dash into area divided by sum of area. So now we have two portions. One is this one, and the second is this one. So if you take this upper line is a base reference line, so you can see this first area, let this area will be equal to A1, and this will be equal to A2. So y1 dash is the center point of this line from this base. So this will be your y1 dash, and this y1 dash will be equal to 30 divided by 2, which is equal to 15 millimeter. Similarly, you can see this 120 if divided by 2 will give you, this distance will be from this point, it will be 60 plus this distance, which is 30. So y2 dash will be from this line till this center. This will be your y2 dash. So now it will be equal to y1 dash into a1 plus y2 dash into a2 divided by a1 plus a2. So this will give you the neutral axis. Okay. So y1 dash is 15 millimeter. So again 15 millimeter in meter will be equal to 0.015 into this area, this shaded area. So 150 multiplied by 30. So 150 in term of meter is 0.150, and thickness is 0.03 meter. Clear? Plus y2 dash. Now y2 dash is this one, which is equal to 90 millimeter. Clear? So 90 is actually 0.09 meter into area A2. So this is the A2 area, which is 0.40 into 120 millimeter. So 0.120 meter into 0.04 meter. Divide by area A1 and A2. So A1 is 0.150 meter into 0.03 plus 0.04 into 0.120. So when you calculate it, you will get y bar is equal to 0.05371 meter, or it is equal to 53.7 millimeter. So what does it mean? It means that if I remove these things clear, so you get a clear idea or picture about that. So let me remove that as well. So we will now explain it. So it means that your neutral axis, let this is the center of this 120. So this remaining distance is 60. But you can see we are taking the neutral axis as the reference line is this one. So neutral axis will be here. This neutral axis, this is your neutral axis. And this will be your Y bar. And it is equal to 53.7 millimeter. Okay. So now we have this neutral axis. I will show it by using red color. This is our neutral axis. Clear? So we will find this I, moment of inertia. So moment of inertia for first this part is equal to 1/12. Breadth is 150 millimeter, so it will be 0.150 meter into height is 30 millimeter, so which is 0.03 whole cube. So this area. Now this area will have a certain center which is at a distance of 15 millimeter. Clear? So this area is away from this neutral axis. Let this distance is d1. So plus a into d1. So area is 0.150 into 0.03 a and d1 square. So d1 is actually 53.7 minus this 15. Clear? So 53.7 is actually 0.0537 minus 15 millimeter is 0.15 whole square. So this is the moment of inertia of this upper portion 1. Now we will calculate the moment of inertia of this portion, which is I will show you, which is represented by 2 plus 1/12. Its breadth is 40 millimeter, which is 0.04, and height is 120 millimeter. So 0.120 whole cube plus AD square, because you can see this center is this one and this is the neutral axis. So we will get this distance, which is equal to D2, and this D2 will be equal to 90 minus this distance. So 90 is this one from till this line to this line, 90 minus this distance, which is 53.7. So 90 is 0.09 meter minus 0.05371 whole square into area, and the area is 0.04 multiplied by 0.120. 1/2 BH cube plus area is this 2 multiplied by these 2 will give you area, and this is D square. Actually what I want to say is that I is equal to 1/12 BH cube plus AD square when centroidal axis does not pass through the centroid of the object, D square. So when you calculate it, you will get the moment of inertia comes out to be 19.162 into 10 raised to the power minus 6 cubic meter power 4. So this is your I. Now what about C? So C is maximum distance from neutral axis. So you can see one distance is this one. From neutral axis, one distance is this one, which is 53.7, and other remaining distance, which is the maximum one, because total height is 150. So 150 minus 53.7 will give you 96.3. So this is the maximum distance, 96.3. Clear? So I will write C is equal to total distance is 150 millimeter, which is 0.150 minus distance of neutral axis from the top will give you this distance. This I will write it, it will be equal to 150 millimeter minus 53.7. Clear? So this 150 in term of millimeter is 0.150 minus 53 is 0.0537. Clear? Divide by sorry, not divide by 2. So this is the distance, maximum distance. So we have C value this. Now you have all the values you can apply. You can put it. Allowable stress is given is maximum bending moment into C divided by I. So you have allowable stress is 25 megapascal. So 25 into 10 raised to power 6 is equal to maximum bending moment. We calculated from maximum bending moment diagram is 2P into C is 0.150 minus 0.0537. Clear? Divide by I is 19.162 into 10 raised to power minus 6 meter 4. So when you solve this, definitely you will get the value of P, and P will be 2.49 into 10 raised to power 3 Newton, or P will be equal to 2.49 kilo Newton. So this is the value of P based on bending stress. Based on bending stress. Now we will calculate same P for the shear stress. So we know that shear stress is allowable shear stress is equal to maximum shear force into Q divided by I into T. So maximum shear stress from this shear force and bending moment diagram is, let me show, this is P by 2 again. So I will write P by 2 into Q. Now what will be the Q? So we will again move to this portion. So you can see here that this is the centroidal axis. So this area will be where we will find the first moment of inertia Q. Now we know that Q is equal to A into Y dash. Clear? So its area, this area is equal to this distance, which is again 150 minus 53.7 into this width, and its center will be this one, and this will be equal to this value which we have written divided by 2. So we will get Q. So I will write it. Area is 0.04 into height is 0.15 minus 0.05371. This is the area, and Y dash is 0.15 minus 0.05371 divided by 2. So this is the value of Q divided by I. I is 19.162 into 10 raised to power minus 6, and thickness is 40 millimeter, which is 0.040. So you have allowable stress is given as 700 KSI, so 700 kilopascal. Okay. So you can put the value 700 into 10 raised to power 3 is equal to this value. I will write it. It is equal to 700 kilopascal. So 700 into 10 raised to power 3. Okay. Now when you solve this, you will get P will be equal to 5.79 kilonewton. So this force P is due to based on shearing stress. Now question is that which one to choose. So definitely our answer will be P is equal to 2.49 kilonewton force. You have to choose that because this is the smallest value that can be applied on the beam, and it will satisfy the bending stress as well as the shear stress. While if you want to use this value, so definitely it will satisfy this condition, but it will not satisfy this allowable stress. So you can check that. So our answer is that you have to choose P is equal to 2.49. So this was all about our problem 11-11. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and press the bell icon so that you can get the notification about my upcoming videos. Thank you for watching.